went through 2 decades, and we're very much at the same point today around the Internet of Things and going to make precisely the same mistakes in the same ways with much more disastrous consequences. So that's the Prezi. The way I think of the world right now is that everything is becoming a computer. And so this phone is a computer that makes phone calls. And your refrigerator is a computer that keeps things cold. Your microwave oven is a computer that makes things hot. And an ATM machine is a computer with money inside. And a car is really a 100-plus computer distributed system with 4 wheels and an engine. And this computerization is coming to everything at all levels. And this is the Internet of Things. These are cyber-physical systems. This is the computerization of everything. This is Mark Andreessen, 2011, software is eating the world. This is how it is eating the world. Like, computers are being embedded into everything, and then everything becomes a computer with different peripherals. And I think we need to understand the things in that way. And for security, it means a couple of things. It means that Internet security becomes everything security. The lessons we've learned from 20 years of Internet security become broadly applicable to everything. And all the mistakes we made, we're about to make again. All right, so here are some of the basic trends that I think informs this. The first, surveillance capitalism continues to define the Internet. That is how companies are making money on the Internet. That is not changing. We're moving rapidly into corporate control of users and customers. We heard a little bit about that yesterday. The notion that companies can use their position as a platform to control user experiences in ways to maximize profits. That's not changing. On the government side, surveillance and control is commiserately increasing, and largely piggybacking on corporate capabilities. It looks different in the US than it does in China, but it's fundamentally the same sort of thing. And that government can use its privileged position to eavesdrop, to control, to censor propaganda, all those same things. Same time, cybercrime is increasing, becoming more profitable, more variable, more robust, from individual criminals to large organized crime. We're seeing countries move into cybercrime. North Korea is. And that is still a defining characteristic of this world we're in. And cyber war seems to be the new normal. Countries doing offensive things in cyberspace. And it's not just that Russia's mucking with our election or us mucking with the Iranian nuclear power plant. There seem to be operations everywhere at all levels. Not all rising to the level of attack, but reconnaissance, preparing battlefield, checking out capabilities. And you occasionally see echoes of this. You see that a good percentage of internet traffic gets routed through China for 15 minutes at some point. And we don't know why, but something's happening. And then occasionally it bubbles up. North Korea attacks Sony. Iran attacks the Saudi National Oil Company. And lots of things going on in this space. Increasingly, we all are in the blast radius. And occasionally, like Sony, it's sort of what happened, but sometimes it's just ancillary. Stuxnet happens, and there's effects around the world. There are new dangers now from automation, algorithms, autonomy. We've heard some of that yesterday, I guess earlier today. A lot of algorithms bring a lot of new factors into this. One that was touched on, I want to mention, adversarial machine learning. You saw that in the Tay example. We're talking a lot about algorithms and machine learning, and there's this whole other area of what happens when the bad guys get to train them. How do we make that work? How do we detect it? How do we solve for it? And that the Tay chatbot is just one example. For me, the important change here is physical action. The difference between computers and IoT devices is that IoT devices do things. I have an IoT thermostat at home, control it from my phone. It changes the temperature of the house. Now, traditionally in security, we're concerned about privacy confidentiality. There's something called the CIA triad. It's not that CIA. Confidentiality, integrity, and availability. The three main properties we want out of a secure system. Traditionally, we were all concerned with confidentiality. Data theft, data misuse. Right? That's the Equifax breach. Right? Today, availability and integrity threats are much more dangerous. So we're concerned about data deletion. We're concerned about ransomware. Those are both availability threats. The data will not be there when we need it. Integrity threats, changing the data. I guess classic would be manipulating a bank balance. But when you get into the real world, the integrity and availability threats are much worse than the confidentiality threats, because there's real risk to life and property. Right? I have a car. I'm certainly concerned that someone can use the microphone to eavesdrop. I am much more concerned that they can disable the brakes. Right? It's very different. And this difference makes all the difference. It's the difference between someone crashes your spreadsheet and lose your data, someone crashes your heart defibrillator and you lose your life. It could be the same CPU, the same operating system, the same software, the same vulnerability, the same attack code. The exact same thing with wildly different consequences. And that's the world we're moving into, kind of without paying too much attention. All right, so what have we learned since the mid-90s? And so we have a bunch of lessons that are immediately applicable. Computers are actually really hard to secure. Bunch of reasons. Most software is poorly written, full of vulnerabilities, and insecure. And basically, it's good, fast, cheap, pick any two. The market has picked fast and cheap, or I guess feature-rich and cheap, at the expense of good, which was mostly okay when it's Angry Birds crashing on your phone. Who cares? But that trade-off is much harder to make now. Second thing we know, the extensibility of computer systems means that anything can be used against us. Now, extensibility is not something that the real world is used to, that we in the computer world are very used to. Now, when I was a kid, I had a telephone, and one of those black things with a cord. Worked great as a phone. The thing about it was, no matter how hard you tried, you couldn't make it do anything but be a phone. That's all it ever did. This is not like that. Right? There's an app for that. Means this can do anything you want. It's a phone. It's a computer first. You could make it do new things. Other people can make it do new things without your consent or permission. And so as these things become computers, they become fundamentally different in their characteristics. Third thing we know is that the complexity of computerized systems means that attack is easier than defense. Now, out in the world, with computers, it is easier to attack them and then to defend them. I can spend an hour on that, but the basic reason is the complexity of the systems. Another thing we know, there are new vulnerabilities in the interconnections of systems. You start putting things together, and vulnerabilities here affect vulnerabilities there, things cascade, secure systems come together, vulnerabilities emerge. Lots of weird effects from interconnections, which of course are growing exponentially. The threats are interlocking. It's another thing we've learned. That it's not enough to defend against one threat, because sometimes the defenses here enable a different threat. You have to look at all the threats together. Again, very hard to do. And the last thing we know is that attacks always get better, easier, and faster. Lots of examples of this. The one I like to use is IMSI catchers. So people have heard of the name Stingray. Stingray is basically a fake cell phone tower. FBI uses it to collect information about who's in the vicinity. The system it's enabled because cell phones don't authenticate. Your phone will basically say who it is to any tower that asks. Now, back when the system was designed, making a fake cell phone tower was hard, was expensive. If that became cheaper, you can buy one on Alibaba.net for about $1,000. You can make your own with a software-defined radio card on your computer. That declined in value. It became an FBI-only tool to an everybody tool. And that's repeated again and again and again. We build things to sort of one tech level, and then the tech improves. So what else is going on? I think another important trend is that patching is now failing as a security paradigm. In the mid-90s, we learned that the best way to secure systems was to produce patches as fast as possible. And your computers and phones are secure as they are, actually, for two reasons. One, there's a team of engineers at Apple and Microsoft, Google if you have one, the Firefox people, sorry, not the Firefox, Mozilla, that are working to design these things secure in the first place. And that same team is on hand to quickly write and release security patches when vulnerabilities occur. You know this is Patch Tuesday on Microsoft. Apple does it occasionally. But that's how we get security. That hard-won ecosystem doesn't work for low-cost embedded systems like DVRs and home routers and everything else. These are designed at much lower profit margins. Teams come together, build them, disappear. They're offshore. You just don't have security teams to write these patches. Even worse, a lot of these devices can't be patched. And right now, the way you patch your DVR against a vulnerability that made it part of the Mirai botnet is you throw it away and buy a new one. That is the patch mechanism. There is no other. And throw it away and buy a new one is a security measure. We replace these things every 2 to 3 years. And every time we do, our phones, our computers, they get more secure. The new designs are more secure. You have a DVR at home, you're going to replace it 5 to 10 years. You replace your refrigerator every 25 years. That thermostat I installed last year, I expect to replace approximately never. Computers don't work that way. And there's a market failure, because in many cases, neither the buyer nor the seller care. Your DVR might be part of the Mirai botnet and now the new one. One, you don't know, and two, you kind of don't care. It works, it's a DVR, what's the problem? So I don't have the same market incentives here. So I have two basic paradigms of security that I'm trying to mash together. The first one comes from the world of dangerous things, and that's the paradigm of get it right the first time. I think of cars, planes, medical devices, buildings. This is the world of certifications and standards and licensing and pre-testing. And then we have paradigm B, which is be agile, from the fast-moving and heretofore largely benign world of software, which is move fast and break things and then fix them after you've broken them. Again, works great for Angry Birds, less well for this building. But what happens when computers look more like this building than Angry Birds? We need to figure out how to make this fit together. Another thing I think we have serious problems is that our authentication mechanisms are very strained. And all of these things work on authentication. They communicate with each other. They need to know who they're talking to. They need to know the information is accurate. Something as simple as cars talking to cars, communicating about their intentions and what their sensors are seeing. That's going to happen to make driving a lot safer. But if it's hacked, suddenly it makes it more dangerous. And computer risks are different. People know how cars fail. Parts have mean time between failures, there are accidents, failures happen at some rate, and we know how to deal with that. Computers fail differently. Computerized cars will all work great until one day when none of them do. And this notion of a class break, that a failure happens to everybody at once, we're used to in the computer world, things are not ready for it. So to me, when I look at this landscape, what I see coming is government regulation. And I see it coming in a big way. Because up to now, we've left computer security to the market because it didn't actually matter. I mean, it's worked kind of mediocrely, and we've all been basically okay with it. But the problems are now going to become considerable. And I think regulation is how we're going to have to solve this. Now, I have lots of thoughts about this. I spent a lot of time on thinking about a new government agency. I'll spare you that. But I think that regulation is coming whether Silicon Valley likes it or not. That being libertarian is all fine when it doesn't matter. When your stuff kills people, it does matter. Right? The stakes become too high. Government's already involved in physical systems. You put computers in cars, you've already got regulation. You put in medical devices, you already have regulation. And our choice is no longer government involvement or no government involvement, but smart government involvement and stupid government involvement. And I think that's how we need to think. And a lot of things follow from that. I'm not convinced we can actually solve the real security problems until we deal with the business and government motivations. That as long as surveillance capitalism is the order of business, as long as cyber war is the order of business, there's too many powerful interests on the side of insecurity and not enough on the side of security. So I always end this with a plea. I don't know if I need it in this room, but technologists need to get involved in policy. That now the fundamental questions of policy are deeply technical. And when you look at things like going dark, Apple versus FBI, you see policy being discussed by people not understanding the technology. And that is going to be a disaster going forward. And unlike previous disasters where it was just computers, it's going to be real disasters going forward because these are now cyber-physical systems. I don't know if, do I have time for questions? Couple. I have time for a couple of questions. Couple equals 2. First.
Who's got do I have the microphone somewhere just for the video recording?
No, because the studio audience needs to, This is being recorded for the internet.
Yeah.
The internet doesn't want you to shout. The internet wants to talk to your microphone.
Thanks.
So I'm curious if you can take your call for government regulation a step further, because you say we're in this surveillance capitalism society or environment where surveillance is in the interests of government and it's in the interests of industry. So if you are on the user side of this equation, and I happen to think there is at least a danger of capture of regulatory agencies, how do you overcome that issue and make regulation an actual benefit for the end user?
So I don't have an answer. I'm hoping we can figure it out. I think we have to. Because regulatory capture is a problem. And we could look at other areas of regulation, environmental regulation. We've had some successes. We've had a whole lot of capture. By and large, I think it's been a success. And I wouldn't want to go back and say, well, we should not have an EPA because it wouldn't work. So I just think we need to do this. And I don't have the prescription of how to do it right when we've done it mediocrely so far. I think we'll do it mediocrely. And people sometimes look at the auto industry in the 70s and that as a model. People sometimes look at worse models. I think we have to give it a shot. And notice I pawned a huge card here by not talking about international. And the international aspects of this are huge in ways that they're not for automobiles. Your question number 2.
Yeah, and maybe you just said something that made me pause, but One of the things that occurred to me just as you were talking is the FAA. I mean, talking about airplanes not crashing into one another. But at the same, airplanes not crashing into one another. But while they do that, and while you still have deregulation and in many cases horrible hierarchical experiences in airplanes. So it takes care of one set of problems, and the sociocultural problems might even get worse.
Right. FAA is a tough model because there are, right, two aircraft manufacturers, very few manufacturers, very few airlines, very regimented industry. Very different than the Internet of Things, which will be everything. And so I'm not sure that model will work. We're really good in the computer industry at dealing with millions of devices. We're terrible at millions of different kinds of devices. And that's where we're moving. So it's not just 3 operating systems and a bunch of computer manufacturers or a couple of dozen cell phone makers. It's going to be a lot. And I'm just thinking about, Apple, keeps what? A dozen operating systems that it maintains? 6 for the phone, 6 for the computer. I don't know what the number is. Some small number. You buy a car today, the software was probably written a few years ago. You're going to drive it for 10 years, sell to somebody who's going to drive it for 10 years, sell to somebody else who's going to put it on a boat, send it to South America, where it'll be bought and driven for another 10 to 20 years. You go boot up a 45-year-old computer right now and tell me how secure your experience is, if you can boot it up at all. We have to solve that. And there's just too many things over too long a time frame for an FAA model to work. It's going to have to be something else. I don't know what it is, but it's going to be something else.
All right.
All right, I'm getting off stage. Thank you.
Yeah, thank you.
Thank you very much.
Great. Okay, we get the next group up. Let's see. Thank you.